We have four special segments of triangles that we need to talk about. The first is called the perpendicular bisector. So the perpendicular bisector is perpendicular to one of the sides of the triangle at its midpoint. So when you're looking for it, you're looking for a perpendicular mark, and you're looking for a side that has been cut into two equal pieces, a bisector. So this is the midpoint. We see the tick marks that mean that it's been bisected, and we see the right angle. So we're looking for right angle and tick marks. The second is the angle bisector, and we've talked a lot about angle bisectors as well. The angle bisector goes through the angle and splits it into two equal parts. So you're looking for the arcs. The third is called a median. We haven't worked with medians a lot yet. But a median starts at the vertex and then goes to the midpoint of the opposite side. So like a median, it has tick marks. Like a bisector, it has tick marks, but only tick marks. You don't see a perpendicular mark. The angle won't necessarily be a right angle. And our fourth special segment in triangles is called an altitude. And the altitude goes from the vertex perpendicular to the opposite side. So once again, we're looking for a right angle. So we have some properties of many of these special segments of triangles. One of them is the properties of the perpendicular bisector. So if any point is on the perpendicular bisector, so here's our perpendicular bisector. If any point is on that bisector, like point C is, then it is equidistant from the endpoints of the segments. So not only do we see this right angle and the set of tick marks that show us that not only does it have a right angle, but a set of tick marks, it is the perpendicular bisector, then the distance from any point on that perpendicular bisector, on that line, has to be the same to each of the endpoints. So the distance between C and A is the same as the distance between C and B. So let's try it out. For example 1, we want to find the distance between E and F. So we notice that FG is a perpendicular bisector. We see a single tick mark, meaning G is the midpoint, and we have a right angle showing that not only is it going through the midpoint, but it's perpendicular to it, or to that segment. And that means that from last chapter, we have a side congruent to a side, we have an angle congruent to an angle, and we have another side congruent to another side. So we have two congruent triangles. Because corresponding parts of congruent triangles are congruent, that means that we can take this 4a minus 15 and make it equal to the a plus 12. And then solve it from there. Subtracting a from both sides, we get 3a. Adding 15 to both sides, we get 27. Dividing by 3, a is 9, but we're not finished. We don't want to stop short. It wants the distance between E and F. So to find the distance between E and F, we plug 4 in for A, and 9 times 4 is 36. 36 minus 15 will get us 21. So the distance between E and F is 21. Example 2 says, let's find the distance between X and Y. When we see that we have a right angle at Y, and we have two segments that are the same distance away from the endpoints of this segment, that means that it has to be, W has to be located on the perpendicular bisector of segment XZ. So once again, if I have two congruent triangles by corresponding parts of congruent triangles, this side YZ has to equal the side XZ, so 22.4 is the distance between X and Y. All right, so that was one of our segments, the perpendicular bisector. We're looking for right angles, and we're looking for tick marks, meaning that we are dealing with a midpoint. Next are the properties of the angle bisectors. So an angle bisector, again, was an angle that was cut into, or an angle bisector is a segment or a ray or a line that cuts an angle into two equal pieces. So if one point is on the angle bisector, then it has to be equidistant from the sides of the angle. So F is on the angle bisector. We see the two arcs showing that the angle was cut in half. And that means that F has to be the same distance away from D, or the distance between D and F has to be the same as it is from F to E. We cut the angles just right, and we're the same distance from the sides of the ray. Any other point along here will be the same distance away from both sides of the angle. So in example 3, we're asked to find the distance between Q and T. So we check and we notice that we have an angle that's been bisected, and we have a distance, the shortest distance between a point and a line is the right, or the perpendicular distance. So we have a right angle, we have another angle, we have our shared side. AT is congruent to itself by reflexive, and so by angle, angle, side, these two triangles that have been formed are now congruent to each other. So corresponding parts of congruent triangles will tell us that QT and TS have to be the same. So 4x plus 8 has to equal 9x minus 7. Subtracting 4x from both sides, we get 5x. Adding 7 to both sides gives us 15. Dividing by 5, x becomes 3. However, we don't know the distance between Q and T yet unless we substitute 3 in for x. 4 times 3 is 12, and 12 plus 8 is 20. Example 4 says, I need to find the measure of angle ZYW. Y is in the middle, so ZYW says I want to find this whole angle. Excuse me, mistake. ZYW, I was reading XYW. ZYW says I need to find this angle right here. Well, we notice that this W is on a segment array that is the same distance away from the sides of the ray, or of the angle. Therefore, since 5 is equal to 5, these two angles have to be congruent to each other. And if angle XYW is 38, then angle ZYW must also be 38 degrees. Our third special segment was medians, and medians split a segment into proportional parts. So if I start with a median from B to the midpoint of E, the midpoint E of segment AC, then I notice that I get a longer portion and a shorter portion. The longer portion is twice as long as the shorter portion. So when all of the medians of a triangle intersect together at a common point, this point G, whatever this segment GD is, AG will be twice as long. And since CF is also a median, whatever GF is, try a different color here, GF, if that's Z, then CG has to be 2 times C. So let's find the distance between G and E. I see tick marks. These tick marks mean we're going to a midpoint, from a vertex to a midpoint, median. Also a median, tick marks again. And one more set of tick marks means the 3 medians are meeting at a common point. If the distance between B and G is 6.4, and that's the longer of the two, to find the distance between G and E, we will take that 6.4 and divide it by 2. And that becomes 3.2. So the distance between G and E is 3.2. Some of your assignment will be simply setting things equal to each other and solving. Others will be doubling or halving if it happens to be a median. And some of your assignment will be determining what you're seeing. Are they angle bisectors? Are they altitudes? Are they perpendicular bisectors? Or are they medians? So you're looking for right angles. Altitudes and perpendiculars bisectors have right angles. You're looking for tick marks. Medians and perpendicular bisectors have tick marks. You're looking for angle arcs. Angle bisectors have the arcs or arches.